the other microphone. Everybody's probably going, where? Oh, there it is. Hey, everybody, we're live right now.
Good morning, everybody.
Good morning. Mark, I turned it on because you were here.
You're the boss.
We have the current chair of the Electrical Safety Workshop. Mark,
Two past chairs.
I feel like I walked into a trap here.
Yes,
you did.
you got to be chair.
That's how I got to be chair. Yes.
Yes. Oh, and we're streaming now, so come on over. So Mark, you're the current chair of the Electrical Safety Workshop.
I am.
Right?
Yes.
What's it like being chair?
A lot of people get to do a lot of work and you get to watch the results happen. So it's not too much stress.
Absolutely.
Unless you overcommitted with a lot of other things beforehand.
Like having a baby.
That's right. You're a new father again, right?
I am, yes.
What's your, is it a girl? It was a girl, right?
A daughter, she's 1 year old now.
Yeah, 1 year old. What's her name?
Ellie?
Ellie. Hi, Ellie.
Turned 1 on Monday.
Turned 1 on Monday. Excellent. Excellent. So what do you think? So how's the workshop going so far? What's your...
I think it's going well. We're back to pre-COVID levels. It's a lot of engagement, but
Yeah.
the best part is almost half of the attendees are first time.
Oh, really?
So
Wow. That's right. We're over 200.
Yes.
Yeah.
So it's really nice to see all the young blood coming in with a lot of interest, and then you have to mix in with the more senior people. So that's how you get that. What do you think?
What?
More senior people.
More senior people.
Well, you get to come in, and they're eager to get that mentorship.
Yeah,
Right.
absolutely.
They want to learn, and it's something that a lot of times they don't get in their workplace.
Yeah.
Right. And that's one of the best benefits of the workshop is to get those contacts if you reach out for a lifetime.
Oh, absolutely.
As you move throughout your career from company to company, you maintain those relationships. It's always people that you can fall back on to help answer questions, deal with new situations, and
Yep.
just get tips and tricks. On
Yeah,
how to do
and
this.
take that back to work and educate others, and that's how we change a culture, which is what the Electrical Safety Workshop is all about.
Advancing the culture.
That's right.
It sounds like a tagline, but that's what we do.
That is exactly right. Well, we appreciate you being chair, and it's been a great program so far. So you've done a great job, and your leadership is very well appreciated.
Thank you very much.
Excellent.
Have a good show.
Go get the show going, buddy.
right,
Thank you, Mark. Be good. All right, everybody.
I guess he ditched me and started live without.
Well,
I'm hurt.
when you got the chair who doesn't want to go live, wait a second, I got to move over this way. When you got the chair who doesn't necessarily want to go live, and you have the opportunity, it's like carpe diem.
I know. I'm still hurt.
You're still hurt.
Broke my heart. We've been doing this for what, 4 days now, and you go live without me. Okay, I went to go look for another guest. I couldn't find him, so I emailed him. I said, just come join us if you see this on fire.
Here,
I'm
I'm going to put this on you for a second because we got a couple jobs ahead of us here. Let's do this. I'm going to grab my iPad. So first thing I want to do, while I'm grabbing that, we had a discussion. Introduce who you are.
Oh, you know what? Just take it. No, take it
Here. Let me give you this. And it's still working.
Getting pinned. There we
There
go.
you go. I'm going to go grab my iPad. Introduce
All right.
yourself.
All right. I'm Scott Seaver. I'm at least a 25-time attendee to the workshop. I was in charge of the expo for years. I was a past chair, 2020. I'm still
guess we have
current
to move
with
this way,
other
right?
chairs.
Yeah.
But what we want to talk about this morning was last night we had the expo, which is an excellent opportunity to learn about new products and services that can impact the industry. And you did a broadcast earlier in the week.
It was,
talking about,
I think it was day one, actually.
was it day one?
Yeah.
Where
Monday.
you talked about how a receptacle was not torqued correctly and it caused a fire.
Yeah.
So at the expo last night, we have a product that we were introducing to people called Edge that would have solved that problem, and I thought this is a good forum to just introduce that. So rather than, this is your basic receptacle, however, there's no screw terminals on it. It's all
Whatever's on the computer screen is what's.
plug and play, so to speak. So you just put your conductor in,
Sorry, I was looking for. Because
you're installed. There's no copper on the side to worry about. You don't have to worry about torquing or retorquing. And we have it in several different varieties. This is a twist lock, but it's the same thing. It's the Hubble Edge insert, and you're installed.
Awesome.
That would have solved the problem.
Right?
Yeah, it's a V-shaped spring that is actually in its natural position now when it's attached, so you don't have to worry about it loosening up over time. And actually, if it's in a vibration situation, it gets tighter. So,
Oh, really?
So, like I said, the expo was very busy last night. We had an awful lot of interest in that product. And if you'd like to think it's something that could save some problems and possibly some lives.
And I have to say, Scott Seaver was a champ yesterday. Like you're running the whole show by yourself.
It
He
was so
busy.
busy. It was very busy.
I know you kind of scaled back, but I don't know for how many years you were running the actual expo, like making sure that
17.
everyone is there, like herding all the cats.
17 years.
It's a big job.
In
appreciate
1998,
it.
Charlie Hoy and I went to Lanny Floyd and said, we've got this expo. It was essentially 4 vendors in the hallway on card tables. And we said, would you be interested in us running the expo? And we didn't even get the sentence out. And he said, yes. So now,
Good idea.
25 years later, we've turned it into a full-blown trade show with over 50 vendors.
Wow. Yeah.
And it's very
And
impressive.
just talk about the expo. I think we talked about this 3 years ago. You know, when we were there, I heard a couple of vendors feedback hoping that there was an extra hour because they were so busy and 3 hours was enough. I know this was back in the day, and then they said it was not too busy last hour.
Yep.
So I guess we can please everyone.
We've all been to trade shows that are one day too long. So we did expand it by an hour, and then we had 1 hour too long. So we went back to 3 hours, and it's kind of a trade show on steroids, but it's very effective, and we're very happy with it.
Absolutely. So your role in the ESW today, I don't know if you covered that. What's your current role that you play with the Electrical Safety Workshop?
I am the chair of the ESW subcommittee. I'm also vice chair of a couple of committees, one of them being the awards that I'm presenting today, because the chair, Kevin Lippert, is unfortunately unable to make it today.
Right.
And I'm also vice chair for another committee that escapes me right now.
Okay. Heavily involved in the ESW, and every year. When was how many years have you been coming to the ESW?
I think it's 25, at least. At least.
We need to start doing what PCIC does, like the 25 timers, they get
I'm not sure if I want to do that.
Yeah, it's just recognition of what you guys do. This is only my 10th year. My first ESW ever was 2013.
I would have said you've been here longer, too.
Yeah.
Yeah,
Seems like, doesn't it?
It
I don't know. It feels like I've been here forever. Like these guys are tired of me. It's like,
Nope.
Well, that's
but I missed, like, we had virtual in 2021 and in Jacksonville, I couldn't travel because of the Omicron. So yeah, it's
Wouldn't
8
let you cross the
ESWs.
border. Yeah, I get it.
And another cool thing
I
about
don't mean to stand in front of you.
another cool thing about the ESW is that new products come to the market through these avenues and the trade shows, and your demonstration and showing your latest wares is awesome. I really appreciate it.
Oh, thank you. I appreciate you having me, and I hope everybody enjoys the workshop. And we're in Tucson next year. First time we've been there, so we're pretty excited.
3 years
about the
overdue.
location.
Supposed to be 2021.
Yeah, I know.
So we had Jay on yesterday, I think it was, Jay Prickmore, who talked about the 2020, it's 2024.
I know. What year is it? I get it. I get it.
Yeah, it's amazing. So excellent.
All right.
Excellent. Cool. Well, thank you. We have another guest here. So let's change mics.
Let's grab you. Cool.
Let's move you over here.
I have things I need to do, so thank you all. Sure. Appreciate it.
Thank you, Scott. We're so glad that you're able to join us because we were trying to get this going a couple of days ago.
Yes.
And Scott is a busy man.
Yeah, I appreciate it.
But I appreciate it, guys.
Yeah,
Good luck.
Appreciate it. Thanks.
Okay. Dr. Braces.
Oh, good morning. How are you?
Good morning. Good morning. Thanks for coming over and chatting with us. Let's shift a little bit your way, everybody.
Oh, this way. Yeah.
There we go. We'll try to be in the middle. So,
Right, yeah.
all right. So, you are going to participate in one of the presentations. Let's talk about. Tell us who you are.
Oh, so Paul Brazis. I'm from UL Solutions. I actually am the director of our R&D organization. And so my core is electrical engineering, and I still manage the electrical and mechanical engineering team, which I've been doing for the past 14, 15 years or so.
Right.
But in the last couple of years, I've taken responsibility for the entire organization. So now fire research, batteries, and electrochemistry, chemistry, material science, and sustainability and chemical health all fall under me.
All under you.
Yeah, so we are responsible for everything under our for-profit business, like all the research that needs to be done.
Okay. So help me understand. You made a statement. The for-profit. There's three different businesses that UL has.
Right. So from 1894, when the company was founded, until 2012, UL was a not-for-profit company. In 2012, there was a change where we still have the not-for-profit parent company,
Okay.
but a good chunk of the company became for-profit. Various reasons we did that, but that's what we now call UL Solutions.
Right.
And then, forget what, it was a couple years ago, the not-for-profit became two organizations. One is the UL Research Institute, which does a lot of fundamental research for public safety. All that information is made public. And then the UL Standards Enterprise is where all our UL standards are housed now.
Right.
So they call that the Power Three. So,
Okay, the power of three. Now, and I know you were instrumental in doing a lot of research on the AFCI technologies, especially when we were trying to figure out what is and what can or cannot be protected from a thermomagnetic circuit breaker. It's always a good
Right.
question. You did a lot of research and you published some papers associated with that. Was that a part of the research foundation? Or I guess it was before the separation of the three different companies.
actually, I think it was immediately after, because I think we did a lot of that work in 2013. I'm trying to remember.
yeah,
It's
you
been
might
a
be
long
right.
time ago.
Yeah, it's been a while.
So I was always part of the for-profit part of the company. I never was on the not-for-profit side.
Oh, is that right? Okay.
So, and actually the not-for-profit right now doesn't have any electrical research. They're mostly, it's fire research, it's, they do a lot of battery, like new chemistries, and then chemical health. That's what they have right now. Oh, and then a material science one just
materials
started. But no electrical yet. So.
Yet. I like the way you said
Yes.
yet.
But but no, that was all done under for-profit. So a lot of my focus really is if customers have issues, or if there might be questions about how the code's going.
Right.
A lot of that does still fall under my team. So,
Oh, excellent,
yeah.
excellent. Well, I'm looking forward to more research in the future on a lot of different topics, and
Right.
hopefully focused on electrical.
Well, it's my core. It's my heart. I mean, that's my that's where I grew up from.
Apparently, you're running everything under the sun. You are like mechanical. Like, I don't even remember how many things you mentioned that you're managing. So
Right.
I think he might be a little busy guy. A little busy. Not that.
Yeah.
Very little. Yeah.
So Nihad last sued us both into this presentation.
Yeah, blame
we
it
have
on
two
me.
presentations today. One is on, well, it's part one and part two of from an arc fault circuit interrupter perspective. So we go over a lot of the history of that technology, and in my opinion, the arc fault circuit interrupter, when you think about when it was created, from an engineering, just being a pure engineer, forget about the business, forget about anything else related to that technology. There was a problem, right? There was an organization and multiple people saying, look, these thermomagnetic circuit breakers aren't doing what we think they should be doing because we're still burning down homes. Right. And there was a misconception around what the technology it was listed. It was listed to UL 489, but UL 489 never included anything that dealt with the low energy arcing and sparking that can ignite fires.
Right.
And then engineers sat down, instead of being, usually a lot of engineers will get defensive about, don't call my baby ugly, right? Which basically they were saying that this device that you have is not doing what we want it to do. They said, wait a second, let's create something that will detect that because it is a problem.
Right.
And it became a technology that we're all experiencing on a residential, let alone commercial and industrial. So, but now he last sued us both into this, and your part, which you're going to come up to, hopefully to the microphone. We got to figure out the logistics on that. I think
Right.
just the general microphone probably down there. If we,
We can get an extra mic, so we'll have to get Paul to walk around to get to that. So get 3 mics, two
would
of us
be
up
great.
there, and then we call Paul wherever he's sitting and stand up and walk around and talk to people.
that would be perfect.
So yeah, that's what I agreed on.
And then you're going to share, because the people who are watching this are probably not going to be in that room. What are you going to talk about?
So basically, I have 2 case studies from my personal life. One was actually an incident that happened in my parents' home,
Okay.
and the second one is in my own home. So the first one is in my parents' house. They actually were renovating. The house was built in the 80s. It's in Northeast Florida. There was they were basically taking a porch area and they were turning it into living space.
Okay.
So the workers actually raised the floor, and then there was flashing put across there. And I got a phone call from my mother saying, I hear buzzing in the corner. And she's like, can you explain like what's going on?
You're an
and
engineer, right?
Right. It's like, hey, my son's an engineer. He knows what's going on. And I'm like, I'm confused because there's nothing in that wall. And then I said, well, the way you describe it sounds like an arcing fault. So start turning off breakers. And then she turned the breaker off. She said, okay, the sound went away. I said, okay, that's an electrical problem. Call your electrician in. And they found a nail through NM cable into the hot, which, people sometimes question if that actually happens. Well, it did happen.
right.
It energized the flashing, and then there was 2 bits of flashing. One was grounded, one was hot, and it was actually going across that point. Now, nothing happened, but it could have
Yeah, for
happened.
sure.
And an
Yeah,
AFCI would have detected that, right?
Absolutely
So
right.
she didn't have them because the house was built before AFCIs were required. So.
Wow, that is amazing.
Yeah.
The second one was actually my own home. I was doing heavy renovation. I had a good friend of mine that's a master electrician, and he was our contractor. And he talked me into doing some of the electrical work. I mean, it was inspected, of course.
Right.
But I had I had to put AFCIs into the house to bring it up to the new code. This AFCI just kept tripping, and he just said, after the inspector leaves, change it out. And to me, like being from UL, I said that that's heresy.
I just didn't know that you did all the research for the AFC.
Exactly, and I told him, I said, just because you call it nuisance stripping doesn't necessarily mean it is. So actually, it was a very difficult thing, but I actually found a 170 ohm neutral to ground fault in a light fixture we just bought.
Wow.
And it was a little piece of metal that was just touching in the right place.
Yeah.
Removed that, and the FCI never tripped again.
Wow.
And I went to him and said, see, I told you, the FCI was doing what it was supposed to be doing. Because the FCI was saying ground fault.
Yeah. And we have another case study that we're going to be talking about as well. And we're going to show a video of some troubleshooting.
Yeah, the electrician and the homeowner kind of
The electrician and the homeowner describing, but it's very similar. Like what you said, the homeowner in that case, when they called us, they got Joe Fellow. Joe Fellow did a lot of our testing for UL on the products, and he worked for me at the time.
Okay.
And he was answering technical calls. So he got Joe Fellow, and the homeowner told Joe that, look, he says, I've had like 5 electricians in here trying to solve this. They said, oh, you need heavy duty receptacles, you need heavy duty switches. They changed the receptacles out, they changed the switches out because it was a bedroom only thing, right?
Right.
And he says, we went through all of that, and then the one electrician actually said, well, we can just replace it with a thermal mag breaker.
Right.
And then the cool thing about the homeowner was an engineer as well. Okay. And he says, no, I'm going to sell this house. And I got to fix this because the home inspector is going to be looking for the AFCI, and I don't want it to be an issue. So he says, we need to figure this out. And then finally he got his original electrician back who did the investigation, and they drilled through a gusset plate in the installation, and they pulled a circuit down to the panel board, from the panel board up to the lighting.
It stripped the whole thing, like all the
And
insulation.
it stripped everything, which, to your research on the home run circuit, and when that came up, and I know on co-panel 2 we had this discussion, and you had people say, well, I don't have to worry about the home run circuit. No, you have to worry about the home run circuit as well as everywhere else, and that was a great example of a homeowner standing up for what they believed in, recognizing that there's a hazard, and then getting it fixed, right? And then
And a dedicated electrician who didn't want to take a shortcut and say, just put a thermal mag and you never have this problem again.
Yes.
Just like
But
what
it's
you
honestly
told
a
me,
shortcut
right?
in his eyes, so he solved the problem.
Yeah.
And there's a perception that there's a lot of nuisance tripping. So you really have to figure out, your AFCIs might be doing something it should be doing. It's probably finding a fault, and it's really frustrating. I found it was very frustrating to find that fault. It took about 3 hours of my time.
It is.
Yeah.
And I finally I was about to tear the new drywall down and start tearing the walls, and finally said, well, let me just start taking the light bulbs out so I can measure continuity between hot and neutral and ground.
Right.
And there it was.
There it was.
Yeah. But electricians are pressed for time. I understand that. But
Yeah. And unlike, so I had a recent issue in my house, which wasn't electrical, right? But it's related in that, in my opinion. I had water coming down into my basement, right? And I looked at where the water was coming out. There were 2 pipes. They said master bath. And I know the master bath is like, because I was in the basement, you have the first floor, then you have the second floor where the master bath was.
Right.
So I'm thinking that I have a problem in my master bath because the water's coming down through those 2 holes where those pipes are going up. So to troubleshoot this, I cut a hole in my laundry area, cut a hole in the drywall, thinking, well, I can always fix the drywall. I cut a hole in the drywall because that's what when you said I got to start cutting the drywall. So I cut a hole in the drywall, and I start feeling the insulation in the wall, and I don't see any water.
okay.
So now I'm like, okay, wait a second. The problem's not up there, and I should have thought about this, but right on the other side is my refrigerator.
Oh.
And when I pulled the refrigerator out, there was a pinhole leak in the water hose for the ice maker, right? I mean, it was such a small leak that when I pulled it out, I see the water. And my
Right.
wife goes, Bobby Joe says, where's that water coming from there? I couldn't even see the stream, but she was at an angle that she could see it, right? But troubleshooting, it doesn't matter if it's the problem with electrical is you don't have electrons spilling out on the floor.
Right.
We don't see them.
You don't see them.
No,
You
no,
don't,
no,
you,
no.
you know, I was able to troubleshoot that from a water perspective because I had a general area of where this leak was. And I was able to narrow it down. And I had some minimal damage to drywall, which I fixed after the fact. But from an electrical perspective, troubleshooting, if you don't have the right techniques,
Right.
it can be very frustrating. And to your point, I can understand why an electrician might say, I solved the problem. But really,
It's time consuming.
master.
Yeah, it's hard.
But and that's the argument I always have with my friend is that false tripping is not the most likely thing to happen. Actually, you've got to eliminate the fact that there is a true fault that's happening.
Right.
Where it seems like in the electrician world, it's like, well, these things are just trouble.
Yeah.
But they could be saving your house.
Oh, absolutely.
Yeah. I mean, that's why they're there, right?
That's why they're there.
So it might be frustrating, but yes, they're probably protecting you.
And I just want to intervene. So everyone watching out there, if you're interested in the paper, we can share it, of course, like to read all the stories. But the one thing I wanted to go back to is I would like to commend, I guess, Tom and his team, Ethan, just interviewing the homeowner and having a video that tells the whole story.
yeah,
And
yeah.
I just want to make sure because it's okay to hear a story from us, but it's a different level of hearing it from the person who experienced it, right? And so what these guys did, they have 4 parts YouTube video, and like
Yeah,
with the
it's on my
homeowner.
YouTube channel, so if you're watching this,
That's why I was mentioning it.
Yeah.
It's on Tom's channel. I think under a playlist. If you go down, there's like the South Carolina homeowner. So he tells his story, the whole spiel, and all the electricians, because he got a couple of electricians did the same thing like Paul's friend, just put a thermal mag, but he insisted. And then the electrician who, like the dedicated guy who found the problem, went and then he disappeared. I think he had some family issues. So
well, no, yeah, he was in the hospital
yeah,
for a while.
yeah, he was sick or something, and then he came back. So he was like a dedicated young guy,
Yeah.
and he found the problem. And I think there was another layer of complexation because the whole arcing was like next to a gas.
It was in his attic.
Yeah.
Okay. And the electrician. So I sent a crew down. There were two people. It was a lady and a guy who videoed things like that. This was, when we're trying to find evidence from an AFCI perspective to support our discussions that this is a problem, and to fight this whole troubleshooting challenges, but or help it. She recorded him, and the electrician made the statement, which I was like floored. He says he had to go up in the attic. And when he went up in the attic, it's a crawl space, there was a gas leak.
Right.
There were like 2 or 3 gas leaks that he had to fix. And that was near the arcing.
Yeah, it was,
And that's what I think when the homeowner, what the letter that he wrote us, he wrote us a letter, and you could tell this homeowner was under, and I can't argue against him, but I can tell him he was actually factually correct, that he saved his family's life, or possibly someone
And I think
else's
the
life.
arcing was in a closet in their bedroom.
It was up in the attic.
Yeah, in the bedroom. So it's like, this house could have just exploded with the gas leak.
That's exactly right.
So
his perspective was that he saved his family's life or someone else's life, and I can't argue against it.
Right.
You can't prove. It's just like people say, like you say, like GFCIs. I had somebody give me a little cross that I still have on my keys, and he says, "You saved my life." And I said, "Well, how did I save your life?" And he says, "I was working in a ditch," he says, "and I remember you talking about GFCIs," he says, "and I knew that I needed to get my cord and I had to protect it with GFCIs, so I went back to the truck." He said, "I made a special trip back." He goes, "I was thinking about your conversation the entire time, and I installed it." He says, "and I'm down in the ditch, and I made a mistake, and I cut a wire." He says, "I would have been electrocuted." I can't see he would have been electrocuted. But in his mind, he believes it, and the GFCI probably saved his life, but you could never prove that it would.
yeah, it's impossible to prove something that never happened. But I guess
Exactly.
back to 7E, likelihood and severity.
severity,
It would have been very likely for this gentleman to get a shock. Maybe he'll survive, maybe get electrocuted, who knows? Because it could be an instant that just like we were talking about this the first day, everyone in the room, I think one of the presenters asked a question, who was ever been shocked, sorry, because electrocuted that you're not here anymore. Shocked, right? And I think like 300, 400 plus people stood up. Because everyone at a certain, I mean, we don't have to be electrical. Anyone who deals with electricity, even if you're not an engineer, chances are you have like a buzz. It's not like a life-changing event kind of thing, but you get the extreme. So those are the things, like how would you know?
Right.
It could have been like something really simple.
Yeah. Right. And that's what I've had people tell me that I've saved their lives, but I don't know that for a fact. And you can feel that. You can say, look, it could have been a shock. It could have been that they touched it and they walked away, and then they de-energized. But the fact that the technology was there and it did isolate the problem is huge. It's huge.
And the problem is, most people tend to forget that any protection equipment like OCPDs, GFCIs, AFCIs, whatever you name it, right? It's not there when things are good. It's there.
You mean when it's not used? It doesn't work.
No, I mean it's not. It's not installed. It's not just sitting there when everything is great. It's there when. There's one time when things go by, something goes wrong.
Yeah.
My analogy is like your airbag kind of thing. We tend to forget airbags. They're sitting there. Hopefully they would never engage. You're just gonna sit there forever. But they're only there for the one time that an accident or something happens.
And hopefully you never use it.
Right. This is what we hope for. But they're very important.
Yeah.
And that's a problem. We tend to forget GFCIs, AFCIs, OCP like breakers, fuses. They are there. And we tend to underestimate their value because they don't do anything.
Right.
And hopefully they never do anything, but you just need them.
And that's actually what a lot of the reasons in the code, some things will work with you violating the code, but there's reasons that these things are there, like grounding and all this protection is there when something goes wrong.
Yeah,
right.
You're right.
Yeah, I've had individuals say, and tell me, a code will change, whether, usually a lot of things are around the GFCI world or whatever, and they'll say, well, that person wasn't qualified, they shouldn't have been in that situation. You know, we shouldn't put a requirement in because they violated the code.
Right.
And I'm like, well, wait a second, that is your last resort. You know, you have to make the assumption that at some point, somebody's going to do something incorrect. Because if everything was correct, I wouldn't need a breaker. I wouldn't need to put a dead front on a panel board. I wouldn't need to worry about a lot of things.
We won't need traffic lights because everyone's just going to stop when they should stop.
Never speed.
We won't need any speeding camera, right? Because everybody's just going to be like.
Well, it's back to your airbag.
This is utopia, right?
If I never crash, I wouldn't need my airbag. I mean, I probably will never use my airbag.
Everything is great.
That one time I do.
That's exactly right.
Right.
Yeah.
This is the thing. It's just like,
So tell us, and from a UL perspective, if there's research or anything that you could share, that what's the up and coming things in the electrical industry that you guys have your microscope in?
Oh my, you had to make it a very open question. Well, I think it's a lot of the big picture things, and in my experience, I would say not necessarily speaking for UL, but maybe for myself. But a lot of the changes in sustainability. I mean, there's a lot of going to renewables and everything, and so we're starting. But it's not necessarily we might be working specifically on sustainability parts, but there's so many product categories that are being affected because of it. So I mean, everything from like energy storage systems is a big one for us, and it's usually on the fire side. More like if an energy storage system does fail. Is the building going to contain that issue? Is it, how much energy is there? There's a lot of important work being done for that. You start looking at medium high voltage things. So it's like DC is becoming important because of our wind farms offshore. So there's a lot of categories.
What kind of voltages are you? When you say medium high voltage, what voltages are you?
So I'm not the expert, but I think it's in the tens of kilovolts.
Okay.
So, and this is even looking at distribution. So I mean, they don't want to actually convert everything to AC and then back to DC again. They actually are sending a lot of that power from the wind farms and for energy storage systems as DC. And then even that touches in our electroshock research that we're doing, because some of the research that was done there was decades old. There was not really a focus on DC or even complex waveforms or another thing that's coming up. And we just have to understand kind of what should those rules be, and we're trying to base all that on science. So
awesome.
Yeah.
Excellent. Yeah, I never thought about that.
This is cool,
And DC, what's interesting is I'm seeing a lot more discussions around DC, even the low voltage. right? The pulsed DC, and I know you did some research on pulsed power, the concepts of, there were products that have claims that we can prevent shock by controlling the pulses, and you guys did research and study around that to say, is that true, is it not true? And then you publish those reports, and that helps the code making panels make rules.
Yeah, I was only in directly with that. I believe that's what they call Category 4 wiring or
now
something.
Category 4
yeah.
wiring.
So it's in the code that way. So.
Yeah, and you have a new standard for those products.
Right, we do have a standard.
Yeah, so I mean, so what's really interesting to me is how the dynamics work. We talk about the trilogy with 70, the National Electrical Code, 70B, and 70E. But in there, and I would say almost wrapped around all of that, are the standards for the solutions that are used in all those applications. Whether it be 70E personal protective equipment, whether it be the overcurrent protection, the conductors, and the listings of those products and their capabilities. And they all work together. And I think the standards are almost like the glue to make sure that everything is going to
In my mind, it's like an ecosystem. They all work
like an
together. It's
ecosystem,
like,
yeah.
you know, you have NFPA, installation codes, say safety, they have their purpose, and then you have the UL standards for products. They work together. You can't just pick and choose. It's just like an all, at least this is my view,
Absolutely.
ecosystem.
And then when you have a new solution, like in that case, it was pulsed power, right?
Right.
So you have an organization who comes up with this new idea that, look, we power everything. My computer's sitting over there, which is actually not plugged into anything right now, which is kind of cool.
Right.
Right. But if there was my power supply, we're converting AC to DC, low voltage DC. So, and the challenges of low voltage DC distribution is the resistance, right? And the voltage drops. So you have to increase that voltage to get a little bit more distance out of it. And they came up with a different way to do something that we've not seen before.
Yeah,
And then it's being applied, and then the standards come along and say, hey, let's do some research on it, and let's create a standard for it so that we know exactly how it's supposed to perform, and it's not hazardous.
But you know, this is cool because it kind of goes back to, I guess, the Edison Westinghouse days of the AC DC fighting,
Yes.
right? The reason that AC prevailed is be transformers.
Oh, yeah.
Like Tesla, he invented that so you can step up the voltage for the losses.
Right.
DC, we couldn't do that for 100 years. Now we have new technology, power electronics.
Yeah,
you
power
can just
electronics.
like they have like buck boosters and like power electronics is not really my thing, but I enjoyed studying it. So you can now change the levels of DC to increase the voltage, lower the current, which means the square of the energy, like by a factor of 4,
Right.
Because that's I squared R, right? So this was kind of the big problem with DC. Now, like just Tom said, his computer is DC. This mic I'm wearing is DC. So why would we generate AC and then convert it to DC? Because every conversion, you lose, what, 20%? It doesn't matter how efficient your system is, you keep losing energy.
Right.
So if you can do the whole thing DC and look around your house, your car, all the electronics appliances we use are DC. But most of them, so not all of them. So
And then you look at electric vehicle, and people ask me about the code requirements. Do we have the requirements in the NEC for the electric vehicle? And I'm like, well, in my opinion, the electric vehicle is a battery on wheels, right?
Yeah.
And we're connecting into the house. So how we connect into the house, that conductor that we use, is the portion that you need to really think about. But we know how to connect batteries to a house.
Right.
and they talk about I would love to be more involved with the vehicle to grid kind of standards. How like you're charging the vehicle, but when you don't need, when your car is sitting there, you can just pump energy back.
Right. That's right.
It's like you're like a little generator, like a battery. It's like a little generator helping the grid when you need power and when the car's parking there.
Or my power went out at my house, and I've got my $80,000 F-150 sitting in the driveway. And it's already plugged in. So can the house tell the truck, hey, I'm not going to give you power, but you know what? I'm going to take about 50% so I can run my emergency loads in my home.
That's no different than the standby generator, like the old diesel generator. Now it's DC. Just it's a transfer switch. Boom, you have yours. But the one thing I wanted to add, I really enjoyed. I had this talk before. These guys are the expert. I'm the new guy. I'm learning. But the cool thing I found about standard is that there's always room for innovation. Because some people would think that because standards are more like the history. It's the way that we document our experience as engineers or professionals. So this is kind of how things work. The way that we think would get the job done. But it doesn't stifle innovation. And this was kind of my argument when I was talking to the gentleman, because there's always room to integrate. Like Paul was talking about the new standard that UL is developing, researching. At some point in time, when they are mature enough, they would join the ecosystem. And then you have the new UL, whatever the numbers are, it would be like talking about this new technology. I just mentioned the vehicle-to-grid standards, that your grid would just communicate, so your vehicle would communicate with the grid. So it's not just like one way. The bidirectional meters, they're becoming very, very popular. Back in the day, the energy was just going this way from the grid, the utility, to the end user. Now, you can send energy back, and then you pay for the difference. And you could get to the point that you're actually making money because you're sending to the grid. I mean, we're not there yet, but ideally in the future, it'd be like generating more power than what you're consuming from the grid. So you're selling power.
Yeah, I'd say we're there.
I mean, not like,
they're doing it, but PV. They're doing that with PV.
But I don't think you get to like the negative. It's just like all the difference. So I think the grid is always higher.
California might argue against you.
I'm not sure. I don't live in California. I don't know. So you can. I mean, ideally, this is the story. You can just, if you're not using grid power, you're just like selling. Utility would just end up paying for you, whatever you're selling to them, and they don't have to build. Like you know how hard it is to get the right of ways and build a new generating station, transmission lines, so forth. So if you have all those millions of electric vehicles on the road, you don't need to build a new power station because you have all those batteries on the wheels.
But somebody has to power the battery.
Yeah, but I mean, because it's a massive investment for utilities to get the land, secure the land, and build like a new generating station, transmission lines, and so forth.
But you know,
so it slows down the thing.
I think the challenge with it today, with this whole technology and electric vehicles, is you need to be able to power that electric vehicle and to get the energy in there, and our infrastructure has to be able to supply that power, and that's going to be the challenge moving forward, I think. And you know, I mean, I think the answering the needs of gas stations, I think that will come. But I really worry about the grid and whether or not we can supply enough energy to
sustain.
To charge all of those batteries.
And you know, Tom, to add to what you're saying, since we are at the Electrical Safety Workshop, we have to do all what you mentioned in a safe manner.
Absolutely.
Do it safely.
I do have to correct one thing that you said about standards, UL developing standards. Actually, we're a partner. So I mean, it is a UL standard owned by our standards enterprise, but it is a partnership with manufacturers and other users and other experts. And UL is only 1 volt.
Yeah, because you have to get all the stakeholders.
And that's why it's important to go to meetings like this, because we have to hear what is coming. Yeah.
And you know, to your point, Paul, and you mentioned this, Tom, before, that the story or the history of AFCIs, which we included in part 1 of our paper, if you look at what happened, the initial, I guess, whistleblower came from the Electronics Association, right? They were observing fires because of VCRs. This was like in the 80s, and TV sets and so forth. And then CPSC, the Consumer Product Safety Commission, got involved, and then there's a problem. It's like in statistics. It took like maybe 10 years with things gonna need time. And then they called in all the stakeholders, UL, like research arm, manufacturers, different kind of manufacturers. Because at that point in time, everyone knew that there was a big problem, but not had a solution. So over the years, like Paul was saying, you had all the people enter the stakeholders, research side, manufacturer side, insurance, laborers, installers, a whole bunch of people built this. This was before my time, but it was an interesting journey, I believe, reading the history. And I guess the outcome of this whole effort was the birth of AFCIs, which is one of the sections that we have in our paper, how AFCIs came into existence. It didn't come to existence because someone just thought it's a cool thing to have, or just wanted to sell a new product. There was a pain out there, and the AFCIs were the painkiller to that pain.
And that's why I think it's a real engineering example, because when you look at everything that, you identified the problem, you identified the challenges, and then some engineers, some really smart people sat down and said, how do I make a device that can look at a waveform and determine if it's good or bad? And that's incredible.
And UL's responsibility was really checking to make sure that it's going to work properly in certain situations.
Exactly.
And also, it's not going to trip in areas that you don't want it to.
Right.
So, and that's really what the 6099 standard is. It's looking at minimum requirements for it.
And to your point, that 1699 standard is developed by a technical panel.
Right.
Of which UL is one member.
Only one
Eaton
vote.
is one
Right.
member, right? Yeah. So you have a whole group of stakeholders. It's an ANSI developed process.
Right.
Governed by the ANSI procedures. So you have to have a balanced representation on that panel to develop and make sure that the standard reflects what we want the product to do in the field.
Yeah, to be a consensus standard, you can just have
Yes.
one entity dominating. And I guess the rules, correct me if I'm wrong, but it's like 1/3. So whatever the technical
Yeah.
STP, standard technical panel, the UL
Right, it cannot
terminology,
be
right?
dominated by any
Yeah,
one
it'd be like
area.
1/3 manufacturer, 1/3 end users, 1/3 research. So yeah, to be balanced, like so no one group can just hijack the whole
The
thing.
idea
and-
is to be a consensus.
Right, yeah, so agreement, and it's a consensus process, which means what we're trying to achieve is to get to some common ground. You're not going to get everything you want. Maybe I'm not happy about something. Maybe Tom is not happy, or Paul, but it evolves. And we were talking about this, I think, yesterday when we were going through our slides. It's like a learning process. The industry, we're all learning together. That's why the NEC is on a 3-year cycle. UL standards, they're constantly being updated because, especially FCIs, it's like a moving target because we have new GFCIs are more established because it's.
Well,
this is what,
I mean,
Actually,
it's-
they're
it's right
evolving
now.
as well.
yeah.
There's nothing in our electrical industry that's stationary.
Yeah,
I mean, we are in such a changing environment. There are so many different, we're introducing harmonics, we're introducing so many different solutions.
Different loads,
so
yeah.
many different
But
players
I guess-
that want to plug into the power distribution system.
Totally.
And everything is a moving target.
Because I'll take it back because what I meant is the detection algorithm of GFCI is very well in terms of differential current. Whatever goes this way has to come back. The challenge, that's why I was talking about the moving target with AFCIs, is the detection method is simply arc signature. And when you have new loads every day, you build your algorithm, and then all of
Now,
a sudden,
the challenge on GFCIs, the algorithm is the algorithm, but now the algorithm is going to change. Well, we're thinking, do we have to change it? Because what about the high frequency currents, right? That's the challenge on GFCIs today, is you have an algorithm that looks at a broad range of frequencies. But then the question becomes, well, I've got variable frequency drives. Now I have some leakage current that are in the very high frequencies over the equipment grounding conductor. Can they kill you? We don't have research beyond a certain frequency that we can definitively say,
Right.
yeah, 40,000 kilohertz won't hurt you.
Well, it's even the other one is just compatibility. And it comes to safety issue as well, as that GFCIs are being expanded in the code into many areas. And I believe it's everything 240 is even included, anything outdoors, even if it's permanently wired. These are product categories that have not had to deal with this problem before. But if we're going to get nuisance tripping, because they just weren't anticipating GSCs in the circuit, what's the solution going to be is probably let's take them out again. And then that's again hurting your safety. So
Exactly.
You want to make sure these things are compatible so that people are using the technology to keep themselves safe. Right.
And there's compromise on both sides. There's compromises, I think, that comes from the GFCI. There's compromises that comes from the appliances. And there's got to be a recognition of, per Article 250, I cannot use the equipment grounding conductor for normal
path.
currents. So I think what's really interesting about our industry is that it's not like other industries where you can see the ramification of what you're doing.
Right.
You can't see these electrons. You don't know what's where, and you have to rely on math. You have to rely on trigonometry. You have to rely on physics to really understand.
and innovation, coming up with a lot of innovative solutions to address something that just didn't exist 10, 20 years ago when this thing, when the product was first
And
introduced.
that's why I'm looking forward to your research in that area, because that's where the research and the effort and the money that we can pour into that effort to understand things from a physics perspective is helpful to code making panel members and manufacturers and everybody else involved to make sure that we all play nice together.
And that's mostly our role, is more looking at the science. And we don't, as research, we don't tend to be in the SDPs and making any kind of decisions. It's more like we're feeding that information saying, this is what the science says, this is what our experiment says, but there's different interpretations to that information.
Exactly.
And it's more of a decision on those partners in STP to make the actual decision what they actually want to set
to make an
standards.
educated decision based on the data that
Right.
you
I'm giving you information to make a more informed, science-based decision.
All right.
more.
Tom, I feel that we already covered, we hit a lot of points in our presentation, so maybe we shouldn't present, just show the video.
no,
We can play the video and we're done.
Yeah, we can play this.
Because we covered a lot of the points that Tom and I were planning,
Yeah.
and of course Dr. Paul joining us. during our presentation, 3:15 Pacific time. Unfortunately, it's not going to be live,
Right.
but maybe we can go live. I don't know.
Everybody out there is watching this got a good flavor.
Yeah, so it's very close, and we can maybe talk about the presentation, like questions, whatever discussions later in the evening or tomorrow morning, whatever the next live.
Well, we have
do.
tomorrow morning, so.
Yeah, 'cause
tomorrow
we leave in the
morning we'll be live
afternoon,
again. We'll be live again tomorrow morning, probably around 7 o'clock Pacific, which is about 10 o'clock Eastern. So please
Join
tune
us,
in
yeah.
and join us. So, all right.
And we hope to see you in Tucson, Arizona,
And we'll
next
see you
year.
in Tucson, Arizona. So.
Tomorrow is the last day of ESW 2023, so we'll be working on, Tom and I on the organizing committee, getting ready for 2024. And yeah, it seems like it's like a year away, but this will start working on updating website, registration, call for papers. There's so many things that happen in the background
Yep.
to be able to have, to set, to organize a successful, at least in my mind, I don't know if you guys feel, a very successful conference that we've had this week.
Excellent. All right. Well, we got to get back over there. Dr. Braces.
Thank you so much.
Thank you very much.
Thank you.
Thank you.
Appreciate it.
Excellent. All right, everybody. You guys take care, stay safe, and please
Stay healthy.
I'm going to sign off.
Is it eaten or is it?
It's like his channel.
Oh, this is